Hi friends, hope you all enjoyed the last sessions. Today we are going to discuss about the decimal expansion of real numbers. So what are real numbers? Till now we discussed about different types of numbers, integers, whole numbers, rational numbers, irrational numbers, natural numbers, etc. So what are real numbers? Simply we can say the real numbers are the numbers which can express or represent on a number line. Or we can say the rational numbers and irrational numbers collectively called real numbers. So we are going to discuss about the decimal expansion of different type of numbers. So let's start with some examples. You find the decimal expansions of 10 by 3, 7 by 8, 1 by 7 and root 2. That means 3 rational numbers and 1 irrational numbers. So you can pause the video, take 10 minutes for finding these values, and after that you continue with the video. So all of it, please pause the video now. I will give you 10 minutes for solving the answers. So what you observe now, when we go through the first 3 questions, it is first one is 10 by 3. When we find the answer, it is 3.333 etc. Okay, so it is not ending. So again that one is repeating in the remainder. And second one, it is 7 by 8. So the answer is 0.875. So when you observe, it ends at after some point, or the remainder becomes 0. And when we go to the third one, it is 1 by 7. So it is going on and the remainders are there. The remainders, and after some point the remainder is again 1. So from here it is again repeating the same procedure. So these are the things that we observe when we do the calculation of the first one. After solving the rational numbers, what you observe? First thing, the remainder either becomes 0 after a certain stage or start repeating themselves. The second thing, the number of entries in the repeating string of remainder is less than the divisor. That is, in the first case it is 10 by 3. Here the divisor is 3. So the repeating number is 1. Only one number is repeating. That is less than 3. And in the second case it is 1 by 7. The divisor is 7 there. So only 6 numbers are repeating. That a block is consists of 6 numbers. That means that it is less than 7. So there is one point that the number of repeating digits is always less than the divisor. And third thing what we noticed is, if the remainder repeat, then we get a repeating block of digits in the quotient. So if it is repeating like that, in the first case of 10 by 3, 3 is repeating. So, and in case of 1 by 7, 1, 4, 2, 8, 5, 7 is repeating. So it will repeat like that. From the above examples, we can come to 3 cases or 3 conclusions. First one, case 1, the remainder became 0. So in the example of 7 by 8, we found that the remainder became 0 after some steps, and the decimal expansion of 7 by 8 is 0.875. We can consider other examples also, like 1 by 2, that is equal to 0.5, and we can take any numbers. In all these cases, the decimal expansion terminates or ends after a finite number of steps. We call the decimal expansion of such numbers are terminating. So we can say they are terminating decimal expansion. Next, we are considering second case, case 2. In this case, the remainder never became 0. In our examples, 10 by 3 and 1 by 7, we notice that the remainders repeat after a certain stage, forcing the decimal expansion to go on forever. That is, it is repeating. In case of 10 by 3, 10 by 3 is equal to 3.3333, etc. And in the case of 1 by 7, it is 0.142857, and again it becomes 142857, and it is repeating. The usual way of showing 3 bits in quotient of 10 by 3 is write a bar on 3. We will explain that later. So all these examples give us non-terminating recurring. Recurring means repeating decimal expansions. So these type of numbers are called non-terminating recurring decimal expansions. So we see that the decimal expansion of rational numbers have only two choices. Either they are terminating or non-terminating recurring. Non-terminating recurring. So we can conclude the decimal expansion of a rational number is either terminating or non-terminating recurring. Moreover, a number whose decimal expansion is terminating or non-terminating recurring is rational. That is, we can represent that in P by Q form. In the coming problems or examples, we can understand it better. Now we consider the third case. So in our examples, when we check the decimal expansion of root 2, that is, we got it as 1.4142, etc. That is, it is not repeating. If it is repeating, we got 4141, etc. But it is not repeating. So if we do further, we got the root value of root 2 as 1.41421356237309. It is going so on. You can read from the board. And like that, if we take the value of pi, it is 3.14159265358979. It is going on. So if we take these two cases as examples, the decimal expansion is not ending, that is, it is not terminating, and it is also not repeating, that is not recurring. So we can say these type of decimal expansions are called non-terminating, non-recurring. And for irrational numbers, their decimal expansion is always non-terminating, non-recurring. I am repeating, decimal expansion of irrational numbers is always non-terminating, non-recurring. So what we can conclude from these three cases, if it is a rational number, its decimal expansion is either terminating or non-terminating, recurring. And for a irrational number, it is non-terminating, non-recurring. And if it is of the form terminating or non-terminating, recurring, we can express in the form P by Q form. And if it is non-terminating, non-recurring, then we cannot represent that in P by Q form.